Okay. Chapter 17, day 1. What are hypothesis tests for proportions? So we've done confidence intervals for proportions, but now we're going to do what we call a hypothesis test. So we're going to make some sort of hypothesis about what we think is going to happen, and we're going to try to generate enough evidence to prove some sort of alternative hypothesis. So let's go through some vocabulary first so that we can all speak the same language here. So first of all, H0 or HO is called the null hypothesis. And so HO, we label that null hypothesis. And that's going to be some known value from some previous study that people have done, previous information, some sort of known previous piece of data. It's going to be some number. Alternative is what we're trying to find evidence of. So this is what we're trying to show evidence using our new data. But just vocabulary-wise, HO is called the null hypothesis, HA is called the alternative hypothesis. So what we do is we write for the problem in HO and an HA. And the HO is written capital P equals, and then this is just going to be the claimed percent written as a decimal. This is the initial percent, but we write it as a decimal. So let's say someone claims that 20% of tree frogs are striped green. Well, P would equal 0.20. So the null hypothesis is always capital letter P equals, and this is going to be a decimal here of whatever the claimed percent is, but we have to write it as a decimal. Now, the alternative hypothesis can be one of three options. We can either say that the data that we got is greater than the claim, so the true value is now greater than the claim, less than the claim, or just different than or not equal to whatever the claim is. But you pick only one of these. Depending on what the question says, you choose one. If the question implies that the new stuff is greater than what you started with, you go with a greater than symbol. New stuff is less than what you start with, or if new stuff is different than what you start with. So, your calculator is going to calculate something for you called a p-value. It's that percent of data that's in the tail of the normal curve. All right? It's the stuff that we looked up when we did normal curves and we found out like what percent is higher than or what percent is lower than. We just call that the p-value from now on. And it's the probability that the data could happen by chance. And it's, when we put it on a normal curve, it's the percent that's in the tail. But it's nice, what's nice is your calculator will calculate all that for you. You just have to know that the p-value then is the probability that the data could happen by chance. So, depending on what the p-value says, we're going to generate a conclusion. So here's the rule of thumb for significant things. If the p-value is less than 0.05, then we say the following. If the p-value is less than 0.05, then we say our results are significant. We reject the null hypothesis, and we state that there's evidence for whatever the alternative hypothesis is asking to show. So if the p-value is less than 0.05, we say the following three items. Our results are significant, we reject the null hypothesis, we state there's evidence for whatever the alternative was asking to show. But if the p-value is not less than 0.05, then we say the following. Our results are not significant. Notice, it kind of sounds like the same thing here, except if it is not less, then it is not significant. We do not reject the null hypothesis, and we state that there is not evidence for whatever the alternative is asking to show. So these three are the same, except not significant, not reject, not evidence, because it is not less than 0.05. On the calculator, this is how you get your results. Stat test 5 now. We're still working with one proportions, but we're doing what's called a test, a z-test. And you're going to enter in the following information. The null hypothesis, written as a decimal, and again, we'll talk about what that is when we see a real problem. X, we already know what X is. We already know what N is. That's the successes over the sample size. And then you select whatever alternative you picked. Remember I said you choose one of 3? Whichever one you picked, you would highlight. Pick one. And the calculator output would look something like this. It's going to give you this information. And so I just made up a phony one where I had an alternative of not equal to, but what you need to get from this is it tells you your z-score, 2.19, and it tells you your p-value, in this case 0.02, for whatever phony problem I just made up. But your calculator gives you the z-score and the p-value, and you just have to write those down. I'm going to do an example and show you kind of how this whole thing plays out. So here's a scenario. In New York, data has shown that 80% of drivers wear their seatbelt. A random sample of 120 drivers from Greece revealed that only 85 wore their seatbelt. Is there evidence that Greece drivers wear their seatbelt less than the state percentage? So, if we go back and we take a look at the null and alternative hypothesis, what is the claimed percentage that they claim it to be? Not from our data. So in New York State, data has shown that 80% of drivers wear their seatbelt. That's the claim. So I'm going to start out and I'm going to write HO, null hypothesis, colon, capital P equals this 80%, where did it go? It's up here. Written as a decimal. So the null hypothesis is that the proportion of people that wear their seatbelt is 0.80. So there's my null hypothesis. My alternative hypothesis, HA, I have to ask myself, are they trying to find evidence that Greece is more than, less than, or just different than the state percentage? So, is there evidence that Greece drivers wear their seatbelt less than the state percentage? Well, so that this proportion is less than the state percentage. So notice the symbol doesn't change, P. The number doesn't change. This number is always equals, and then this number is either less than, greater than, or not equal to based on what they want. Evidence of less than. So I've written HO, I've written HA. So now I need to identify X, N, okay? So my X and my N. So X. Well, N we know is total sample size, 120, and X is the part, which is 85. So 85, 120. So now I go to my calculator, okay? So I'm going to go stat, over to test. Remember, option 5, one proportion z-test. All right, so my null hypothesis, well, I gotta go back to my paper. My null hypothesis is 0.80, and again, that came from, not from our data, but from the claim of what we know previously, 0.80. All right, so my null hypothesis is 0.80. My X is 85, my N is 120. My X is 85, my N is 120. Now my alternative, not equal to, less than, or greater than. So I have to look at the direction that this symbol is heading. So the pointy part is to the left, the big mouth is to the right. So I have to select that same exact symbol, which is, hang on 1 second. Okay, so I have to select this symbol. And now I go down, I hit enter. Whoop, I gotta go down first. Go down, calculate, and there's my output. Z is negative 2.51, and P value, that's what this is, P value is 0.006. So Z is negative 2.51. I have to record my Z, and my P value is 0.006. Again, I'm getting that off the calculator. Z, negative 2.51, and P value, 0.006. Okay, so now I've identified my null and alternative hypothesis, I've identified X and N, I've identified my Z and my P value. So let's go back to this. Okay? If the P value is less than 0.05, or if it's not less than 0.05, that's what we have to determine. So 0.006, that's less than 0.05. So less than 0.05, then we say the following: our results are significant. So let's go to, whoops, sorry. So, conclusion. Our results are significant. All right, I'm going to write that right out. Second thing. We reject the null hypothesis. And then we state there is evidence for whatever the alternative is asking. Okay? So, conclusion. Should be 3 bullets. Our results are significant. We reject the null hypothesis. There is evidence that, and I'm going to go back up to the question. What did we want evidence of? Well, they said, is there evidence that grease drivers wear their seatbelt less than the state percentage? So there is evidence that grease, I'm just going to repeat it, drivers wear their seatbelts less than the state, and I'm just going to abbreviate percentage. Now, if it was not less, we would have said our results are not significant, we do not reject the null hypothesis, and there's not evidence that grease drivers wear the seatbelts less than the state percentage. But in this case, we were less. Those 3 bullets you have to have in your conclusion. And that's a problem from start to finish. You first state your HOHA, then your X and your N, your Z, your p-value, and write your conclusion. Okay? So, again, steps. Step 1, state HO and HA. Step 2, identify X. X equals, N equals, all right? You need your Z value, you need your P value. And then just the last thing you're gonna do is write your conclusion. 3 bullets in your conclusion. All 3 have to be there. Okay? Calculator does all the hard work, all the math calculation work. That's it.